In this video I'm going to show some more of the aspects of the Hurricane Mitch lab for natural disasters, which uses some GIS methodologies to learn some more about the Hurricane Mitch storm. What I have loaded right now is what's indicated at just before step 33 on page 8 of the instructions that came with this lab. The first question one of the questions that's being asked right here is to compute or measure the size of the eye of Hurricane Mitch at the time when satellite image 2 was taken. The easiest or the better way to do this is to zoom in a little more to get a real clear view of the size a clear view of the eye, and we go ahead and use the measure tool, which is up here in the upper right of the screen. Measure tool allows us to calculate an area, a distance, or a geographic location using whatever units. We're going to use the distance measurement and measure it in miles. This part of the this whitish part right here is actually part of the eye wall, the intense winds and clouds in the eye wall of the storm. So when we do our measurement, I'm going to measure from this part of the storm to this part, and it shows 22 miles. I'm also going to measure in the other direction to get a more accurate measurement, and I'll click in the other direction. It gives me about 26 miles. So I would say that averaging those two, about 24 miles is the diameter of the eye of the hurricane here, which is actually the answer to question 7. Next group of questions here, or activities for this, is to fill out a table which measures, or which helps you to record a number of measurements for Hurricane Mitch at days 2, 3, 4, and 5, measured by satellite images 2, 3, 4, and 5. What I'm going to do is I'm going to zoom back out so I can see the entire size of the storm. The table asks us to find the diameter of the eye, the diameter of the entire storm, how far away the storm eye is from the coast of Honduras, and the change from the previous day. So let's go through some of those quickly and see what we come up with. That's day number 2. We have a 25 or 24 mile diameter of the eye. Measuring the diameter of the entire storm now, I think I'd probably just say measure from here to here. Probably the largest diameter, which would cover the whole storm, is about 815 miles is the total width. And then the last measurement would be measuring from the eye of the hurricane to the coast of Honduras, how far offshore it is. And it looks like it's about 111 miles, roughly measured in this case. And since there wasn't a previous day when this thing was as a powerful hurricane, there's really no change from the previous day. We can go ahead and continue to fill in the table by next looking at the image of Hurricane Mitch on day 3, which is shown here. We can actually right-click. Oh, no, that's not going to do it. We can actually click on this drop-down button right here and say Zoom to, and it'll actually zoom to the image. It didn't help very much, but it did zoom a little bit to the image. Looking again at the eye of the storm here, and maybe we ought to zoom in on the eye in order to make a better measurement of it. So measuring again, the eye of the storm is approximately from here to here. Looks to be about 17 miles, 15 miles in that direction, and in this direction it seems to be about 13 miles. So I'd say on the whole, I'd say it's about 15 miles is the size of the eye showing here. Next we'll want to zoom back out again so one can see the entire storm and make a measurement of the size of the entire storm, which is about from here to probably as far over as here. and probably there seems to be a few more rain bands of this further out. So I would say that this storm probably is on the order of 950 miles across its whole diameter, maybe even 980 miles. So that would be a good answer. What seems to have happened since the previous storm is, one other measurement is to measure the distance from the eye to the coast of Honduras, which seems to be about 55 miles. And actually what's commonly occurred here is a visible difference, which is common among hurricanes, is that it's actually gotten larger. The patterns of clouds and swirls of rain bands are even more intense. So the storm is even larger. The eye is actually contracted. The eye wall is even more intense than it was, and the storm has moved a little bit closer to the shore of Honduras. So those are some of the changes that have occurred. I'm going to pause the video here and pick up again momentarily with question 20, and I'm leaving you to compute Hurricane Mitch 4 and Mitch 5 measurements. Do want to point out it is possible in this case to not be able to measure the eye of the hurricane. I guess I've given that away, that there's no actual measurement of the eye of the hurricane because it's not visible here. It's starting, the structure of the entire storm is beginning to fall apart, and seems to be that the storm itself, the eye, which seems to be somewhere in this vicinity, has actually gone on shore. So that answers a few more of the questions as well. Continuing, what I've done now is I have turned on Mitch 3, which is the day 3 satellite imagery, and I can turn on and off Rain 3, which is the rainfall pattern for day 3 as well. And the next series of questions are intended to help you analyze the pattern of rainfall with respect to the land masses and the satellite image itself. So turning the rain back on, what we notice for question 20, which is an analysis of day 3 and rain, the day 3 image and the day 3 rain, is we do see a concentration of rainfall in the vicinity of the eye in the most intense part of the storm right here. We will also see a significant amount of rainfall and rainfall around the whole storm in general. The highest concentration of rainfall is actually in the southwestern arm of the storm, and it seems like this is the part of the part of the Central America where the rain was the most intense. The fact is that the winds are blowing from offshore to the mountainous areas of Honduras, and it's topographic effects that are causing the wind blowing inward, swirling inward in this direction, to cause the largest amount of rain to occur right here because of the mountainous nature of Honduras. At first, in question 21, is this a pattern you expected to find? Now that I've explained it to you, that it has a lot to do with winds, moist air being blown in by winds from offshore and hitting the mountainous areas, now it makes sense. Originally, you may have assumed that the largest amount of precipitation was at the eye of the hurricane. Let's see. It's now asking us for question number 23. Which country received, or no, question 22, what is the highest range of rainfall in Rain 4? So we'll turn on the Rain 4 layer. And in this particular case, the highest range of rainfall is the brownish orange, which is actually 24 to 28 inches, the answer to question 22. And that rainfall seems to be actually most impactful to Nicaragua. We can just see the last of the name of Nicaragua. So this is Nicaragua, and this is the most intense precipitation. Much of the intense precipitation ended up falling offshore. So question 23, the answer is Nicaragua. Question 24, I'll pause for a minute. Question 24 is a comparison between Rain 4 and Rain 5, and it's just a geographic comparison. There's a much larger total pattern of rain as the storm gets bigger as it reaches day 5. So a much larger total area of rain is covered, as we can see on day 5 as compared to day 4, where the rain is much more intense but more concentrated. And you can also make other kind of observations here as well. And finally, question 25 is a discussion, and you should be, this is a question that asks, what kind of damage do you expect to find? Well, there's, as we know, intense precipitation in as many consequences. Answers to question 25 could be flooding, which was an enormous problem, which is directly related to precipitation. Also, because of the steep slopes, and many of them being deforested, especially in El Salvador, Nicaragua, landslides were a major issue. And of course, when there's landslides and flooding, those can cause a lot of damage to roads and utilities, and they can bury crops. So just about any of the consequences of intense precipitation, especially in mountainous areas or steep areas that we've discussed this semester, would be good answers to question 25.